Welcome everyone to another video of Smart Pathshala. So in this lecture we'll see some problems on conditional probability and how to solve conditional probability or what is conditional probability, and then we will see the independent events, how can we visualize the independent events, and we can solve the independent events. Okay, so let's start with the conditional probability. Okay, now say we are having an experiment E, okay, in which we are having a sample space S. So obviously if we are having a sample space S, then we are having two events from this sample space as A and B. Okay, now the probability of occurrence of say A, now on the hypothesis that actually B has occurred. Okay, so you will be given that B is actually occurred prior. Okay, now you have to find the probability of A. So this is called nothing but the conditional probability. So it is very simple. Okay, so you will write it P of A given B. Okay, it is right by this symbol. Okay, so we read it as P or probability of A given B. Okay, we read it like this. Fine. Now let's move on. So this is a theorem of compound probability. Now it says that suppose we are having an experiment E where we are having an event A and another event B. Now the probability of occurrence of A and B simultaneously is nothing but the product of probability of A into the conditional probability of B given A. Okay, so this is nothing but the conditional probability B of B given A, because we are trying to find the probability of B given A. Okay, so this is nothing but the theorem of compound probability. Now from the theorem of compound probability, if we see that P of A is not equal to 0 and P of B is also not equal to 0, then this formula we have got is P of A intersection B as P of A into P of B given A, right? So this is called the multiplicative rule of probability. Okay, now based on this two theories, we will solve the next problem. Okay, now let's move on to a problem. In this problem we will distribute the problem piece by piece. Let's say we have a bag contain 6 red and 4 white balls. Okay, so we are having one bag. Okay, so where we are having 6 red balls and we are having 4 white balls. Perfect. Now 2 balls are drawn at random. Okay, one after the other. First we draw one ball, suppose ball 1, and then we draw another ball B2. Okay, now find the probability that both the drawn ball are white. Okay, so you need to find the probability of both the drawn ball being white. Okay, so now we can assume that the first one is white and the second one is white also. Okay, now remember we are mentioning here first one and second one. So when and there is and, there is obviously intersection. So this logic I have mentioned you on the previous lecture. So if you are not accustomed to and or, then obviously go back to the first lecture of probability, then come back here. Okay, now so let us solve this problem. Okay, say let W1 is the event of getting white ball on first draw. Okay, suppose on first draw we are getting the white ball. Similarly W2 is the event of getting white ball on second draw, right? Okay, now what we need to find out is that probability of W1, okay, and the probability of W2. Okay, now one thing you need to know that we have been given two conditions. Okay, so what is the number one condition? Number one condition is that it has been given that the first drawn ball is not replaced before the second drawing. Okay, now what is the probability of getting the first drawn ball being white? Okay, so we are having total balls as 6 plus 4, which means we are having total 10 balls, and white balls only 4, so that we are having P of W1 as 4. Okay, now you have 2 by 5 as P of W1. Okay, now see the probability of getting the second ball. Okay, the probability of getting the second ball being white and the first ball, when we write it using this multiplicative rule, this rule we will have to write P of W1 given that P of W1 given P of W2 given W1. Okay, so what is P of W1? P of W1 is nothing but 2 by 5. Okay, now in this number one condition we have been given that the first drawn ball is not replaced. Okay, it's not replaced, which means we are having 10 balls over here, then one white ball is out. Okay, so we are having now 9 balls and white ball is only 3, so we are having this 3 by 9. Okay, so obviously P of W2 given W1 is 3 by 9. Okay, so you just have to simplify it so that you can get 2 by 15. So that's the result. Fine. Okay, now let's solve the second one. In the second one we have been given the same thing, W2 intersection W1, so we will write it accordingly, P of W1 into P of W2 given W1, right? Okay, so what is P of W1? It's 2 by 5, right? Now in the second condition it's been given that the first drawn ball is replaced, which means you draw this ball and then put this ball again into the box, which means here again you are having 6 red ball and 4 white ball, so you are having total ball as 4 and white ball as total ball as 10 and white ball as 4, which means you are having the probability of getting white ball is 2 by 5. Okay, so you just multiply here 2 by 5, so you are getting 4 by 25. So that's the way in which you can solve the conditional probability problem. So after that we will see some other problems in the next videos. Okay, now let's come to the topic of independent events. Okay, so suppose two events are independent. Okay, so here just correct that here is we can to write stochastically independent events. So these two events are stochastically independent if and only if when P of A intersection B will be equal to P of A into P of B. Okay, so we actually can prove it. We can prove it. How we can prove it? Just recall the multiplicative property when we used to write P of A intersection B is equal to P of A into P of B given A. Okay, now we are saying that these two events are independent, which means A and B are independent, right? So they are actually independent. So when they are independent, so occurrence of B with the given A does not depend on actually occurrence of A or not. If it is given that A has already occurred, so whatever effect it will come on B is irrespective of occurrence of A. I think you got it. So that's why you can write directly this term as P of B. So as this term is written P of B, just substitute this value here so that you can get P of A into P of B. Okay, now if you are having some doubt regarding theories, kindly contact us so that we can clarify you guys doubt. Okay, now let's solve another problem of independent probability or independent events. Okay, so in this problem what we are given is that we are given two boxes, right? So one box is like this, where you have 3 red balls and 3 blue balls and 4 white balls. So this is one box, the box number 1. So this is box number 2, suppose. Okay, so here you are having 5 white balls and 4 red balls and 3 blue balls. Fine. Okay, so what it's been asked is that if one ball is drawn from each box, that is, you are taking out one ball from here and another ball from here. Okay, what is the probability that both the balls are of same color? That is, they should be same color. If you are, suppose balls drawn from here will be denoted by, suppose whatever it will be denoted will be having suffix as 1, and whatever here it will be coming out, suffix will be 2. Okay, so suppose you are getting red ball over here on the first draw. 1 means first draw. So on the second draw, what is the probability that you will be getting R2 over here also? Okay, now remember, the occurrence of R1, okay, does not actually influence the occurrence of R2, because the total number of red ball and the total number of balls in this box 2 is independent from the effect of this ball 1. So if we say that the probability of occurrence of R1 and R2 simultaneously, so they are actually independent. Okay, so if they are independent, we can write directly as P of R1 intersection R2. Okay, so so you need to write them in a in a representative way. Okay, so you need to represent it in a perfect way. So to represent them in a perfect way, first need to write that R1, B1, W1, okay, are events of getting first ball as red, blue and white respectively. Okay, now similarly R2, B2 and W2 are events of getting second ball as red, blue and white respectively. Fine. So I have mentioned earlier that P of R1 intersection R2 are independent, which means P of R1 into P of R2, you can write that. So what is actually P of R2? So P of R2, sorry, what is actually P of R1? Now let's calculate P of R1. So you are having 3 balls over here. So total number of ball is 3 plus 3, 6 plus 4, that is 10. Okay, so P of R1 is nothing but 3 by 10. Similarly, P of R2, what is P of R2? Here you have 4 red ball, so that is 4 by 12. Total ball is 12. So hence you are having 4 by 12, and we will say 12 by 120. Similarly, if you are getting the red color ball, you can get also the blue color, you can get also white color also. Okay, so you are having 4 white here. Fine, so you can get also 4 white color. Okay, and you can get here 5 white color. So similarly, you can calculate B1 intersection B2, which means P of B1 into P of B2. So what is P of B1? Probability of getting blue ball from the first box. So there are total 3 blue balls and total balls is 10, which means you will be having 3 by 10 into, so B2 means blue ball from here, which means you have only 3 blue ball on the second box. So you have 3 by 12, which means you have 120, and that is 9. Okay, fine. So that's pretty simple. So again, you can get also white balls, which means you are having P of W1 into P of W2. Okay, so you first need to find P of W1. Okay, so when is P of W1? W is 2. Okay, you have 4 white balls over here, so you just write 4 by 10 on the first box, and on the second box we are having 12 balls. And how many white balls you are having here? So you are having here actually 5 white balls, right? So you just write 5 over here, and then you will get 20 and 120. Okay, so see, you can get 2 red balls, you can get 2 blue balls, you can get 2 white balls also. Okay, so now what if you need to calculate probability of A is such an event where both the balls are of same color. Okay, so actually you need to find out this probability according to the question. So that question is, you can get a red color, that is both the ball that is red, and also you can get both the ball as white. Similarly you can get both the ball as blue. Fine. Okay, just write it down. So what is P of R1 intersection R2 is 12 by 120. So that's 12 by 120 plus, okay, W1 intersection W2, that's 20 by 120, and then B1 intersection B2, that's 9 by 20. So you just add them up so that you can get 21, and that is 41. So yeah, so that's the result of your problem. Okay, so in this way we'll solve some other problems from this topic. Okay, so these are the 2 problems from one topic, independent events and the conditional probability. If you are having any problems, kindly write it down in the comment section and let us know your thoughts and the way by which we can improve our channel. Okay, so I am also mentioning the topic that we are going to study on the next lecture, and that's the Bayes theorem. So we are going to study the Bayes theorem on the next lecture. Okay, and we'll solve 1 or 2 problems on the Bayes theorem. This Bayes theorem is very much required for NCERT. Okay, and also you can say in CBSE board, also in ICSE board. Okay, so even if this Bayes theorem you can find in some competitive exams like GRE, GMAT. So this Bayes theorem is a very important topic. So kindly follow our channel, subscribe and like and share with those who can use our material as revise or something like that. So there is an announcement that we will solve all the miscellaneous problems. Okay, miscellaneous problems of NCERT book. Okay, so we'll solve all the problems from mathematics section. We'll solve all the miscellaneous problems of NCERT of class 12 book. Okay, so you can get that after the theory part gets completed from all the chapter. Fine. Okay, so see you on the next video. Stay safe, stay at home. So goodbye.